So I have this Les Miserables ebook here. It's about 3.2 megabytes, but watch what happens when I run it through this program I built in C. So here you can see it's 3.2 megabytes, but if I run it through my Huffman program, okay, now let's check the sizes. So the Huffman file that my program generated is 1.9 megabytes. So this lesmiserables.txt.huff is a Huffman file that is a compressed version of this file here, and I can actually recover this file just from this Huffman file alone using my program. So I'm going to use my program again. So I'm going to use the decode option here and then run this. So it took that Huffman file and created a new decoded file, and this decoded file is the same file as the one that I encoded earlier. So if you can build this program, you're not just a coder, but you're a software engineer. And I'm going to show you why this program, building this program here, is the filter that separates junior developers from senior developers. A lot of beginners start off doing to-do list applications and calculator applications, and those are good applications to build when you're starting off, but there comes a point when you can't build these kinds of projects anymore. You have to build something that's a little bit more complicated that will actually teach you how the computer actually manages data. And nowadays, there's a lot of APIs that you can use, that you can call, and then you can actually build a lot of cool projects using these APIs. But the problem here is that you're not really learning anything about data or how the computer manages data. Like I said, you're just learning how to stitch together some APIs to produce some sort of project or produce some sort of program. In order to bridge that gap from being a junior developer to a senior developer, you need to start building projects that rely less on these magic libraries to do everything for you and requiring you more to manage your own memory, handle your own pointers, and pack bits into bytes. And this is why I really like this project. So say, for example, you have this mississippi.txt file. So there's about 11 characters here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And in ASCII, each character here is, when we store it in memory, if you know ASCII, it's going to be 8 bits, which is 1 byte. So there's going to be 11 bytes here, 1 byte for each character. And you can see it here that it's 11 bytes. But there's something cool here. When you use a Huffman tree, you can actually encode this data using less bits. And the way it works is we look at which characters have higher frequency. So we do a frequency analysis here. We can see that S happens pretty frequently, and then we can assign a bit code to it, like maybe 0. So every time we see an S, we replace it with a 0, like a 0 bit. And then with I and then P and then M, we can assign corresponding bit streams for those characters as well. And then when you stitch them all together, then you're going to take up less data. So this is how we programmatically do it. We create this Huffman tree based on the frequency analysis. And this Huffman tree requires you to know how to manage data, how to manage your pointers. And this is why this is such a good project that helps beginners become better programmers, because they have to think about how to manage their memory well. And then you have to assign codes to them. So like I said, S has a high frequency, so we have a smaller bit code that is assigned to it. And then I is a little bit more, actually has the same frequency, so we assign a small bit code to that too. And then you can see here, well, there's only one M in this string of characters. P is 2 times. So what we do is we replace M with 100. So M gets this code 100, I gets this code 11. So just to make it more clear, after we build that Huffman tree, we're able to assign these bit codes to these characters. So 100 is corresponding to M, 11 is corresponding to I, 0 corresponds to S, and so we just keep replacing these, and we do this in our program, in that Huffman program, and eventually you just have this stream of bits, and this will take up less data in your computer than Mississippi itself. So if you look at this, how many bytes is this? This is 1, 2, 3, 4, 5, 6, 7, 8. So that's 1 byte there. 1, 2, 3, 4, 5, 6, 7, 8. That's another byte there. And then we have this. So now we're able to store Mississippi in like 2 to 3 bytes instead of 11 bytes. And if you're a developer, you know you can't just store a byte that doesn't have a complete number of bits. So we have to pad it here with some zeros. So this way we have a full byte of data here. And then so we're basically going to compress this Mississippi text file into just these 3 bytes. And so we're able to compress it from 11 bytes to 3 bytes. But then you also have to programmatically know when does the file end. And so this takes some architecting on your part as a developer. And this is why I like this project. So here in the File Explorer, you can see how I built this project. So I have a bin directory, an include directory, and then obj directory, and this is just for all the object files that were built. And then we have our source directory, and our source directory has different modules. So we have a decoder, an encoder, frequency is for the frequency analysis, and then we have the main program here, and then priority queue is for building a priority queue, and then the tree here is for building our Huffman tree based on that priority queue. And then we have a utils.c that will give us some utility functions that will help us get things organized in our project. And then we have this test directory, and then I have a makefile here that will compile all of these C files together to generate my Huffman executable over here. And so I like this project because if you're building programs as a beginner, sometimes you just code everything in your main.c. But this project is so complex that you need different C files as different modules in your program, and it teaches you how to architect your project, how to organize your logic, your C logic together, and then how to think about different parts of your code base. So this project gets you thinking about your code base as a whole, like how to make sure that all the files are in appropriate directories and how to compile them together into one executable. When you can organize your code in a clean project structure like this, it helps you with your development, so you're developing things incrementally and modularly, and then you're able to focus on the modules you need to focus on, and also helps you navigate your code base correctly. So you know exactly where all the decode logic is. It's going to be in this file here. All of the encode logic is going to be here, etc., etc. I recently had a student go through this exact project, and this is what he said at the end. He said, after learning bit manipulation in C, I understood how data is represented at a binary level and how to efficiently control and modify individual bits using operators. I learned how to set, clear, toggle, and check specific bits. Bit manipulation also improved my understanding of how integers are stored in memory and how flags and masks work. Then after he finished the project, he also said that he was absolutely elated and literally danced in joy because it was a significant achievement for him. So if you want to build this project, I help students build this exact project in my ProDev Sprint program. You can check it out in the link below. And in that program, it's a 30-day program where every week I will give out weekly videos, weekly lecture videos on the theory that you need to know in order to build this project. And then at the end of each week, I will also review your code. So you can also turn in your code to me. I can review it, point out anything that's missing. And even during the week, I can also answer questions. We're going to have a Discord server, or we have a Discord server where you can ask questions, and then I can give some input, give some answers, give some hints on how to solve the issues that we go through in this sprint. And so you can check that out in the link below, and I would love to help you out. So that's the Huffman Compression Engine project that I truly believe separates junior developers from senior developers. If you can code this project, then I believe that you can code anything that you set your mind to. And so that's it for this week's video. I hope it gave you some inspiration on what kind of coding project you can do to get yourself to the next level. And if you have any other questions, feel free to let me know in the comment section, and I'll be sure to answer you there. And I'll see you in the next one. Peace.